Okay, so let's dive into Unit 1. We're talking about kinematics. Okay, so the way kinematics works is we're going to talk about descriptors. So the first descriptor we're going to look at is really answering this question of how far. Okay, how far does something travel? In fact, there's actually one before that of how long does it take, and that's going to equate back to time, which will be measured in seconds. Okay, so when we talk about this, the first thing we're going to need to do is we're going to talk about a frame of reference. So describing motion requires a frame of reference to specify how objects' positions changes over time. Now, in physics, frame of reference to us is going to be referred to as a coordinate system. So you've heard this term coordinate system in math before. What that really does is your x, y, right? And really what the coordinate system does is establishes where positive and negative are, right? And so usually you define positive x and positive y. So it's the same thing here in physics. But our x is no longer going to be defined as x, our y is no longer going to be defined as y. We're going to give those names, right? We're going to give them different kinds of names. So the first part of identifying a coordinate system is to establish the origin. In math, it's that point 0, 0. Okay. For us in physics, is when our position equals 0 meters. Okay. Um, the way we can think about it right now in physics is it's like a number line. Okay. And so if I'm establishing a number line, there's my 0 point. Okay. Now, one thing to note, it also establishes positive direction. Sorry, I wrote over the top of that. So numbers to the right of the origin are positive, numbers to the left are negative. Now, the first descriptor of motion is going to be position. So where is an object located or where has it been placed? You can be located at the origin, you can be located in the positive direction, you can be located in the negative direction. So this is now where we're just taking an object and we're taking it from one spot, right? We're going to place, excuse me, we're going to place it at one spot. So what you'll see here in this picture is that this person is starting. So there's some key things that we talk about here. The first thing is, right, so actually this is the first thing, the origin where x equals 0. So anything to the right of that point will be positive. And what you see here, it tells you the arrowhead indicates the positive direction. The first thing we need to figure out is where do they start? And that's what we call the initial position. It's going to be xi, or sometimes you'll see it written as x0. Okay. Now, the last part, especially with motion, we're going to move from the initial position to the final position. Okay. And so you could see there's two ways, it's xf, or we just call it x. These two here are conducive to what the AP test calls it. Okay, xf, xi is good to remember if it's final and initial, right? Because then you got f and I. But for the AP test on the AP equation sheet, you'll just see it as x0 and x. Okay, so that's the first descriptor. Now, the second descriptor, or where we go from here now, is what happens if it begins to move, right? So that motion from initial to final. And that's where we get into this discussion about distance versus displacement. So when I walk from one place to another, you want to know how far you traveled. Okay. And so what we're talking about here is we're talking about the distance traveled. Now, more formally, the distance is defined as the total length of path taken on a trip. The SI unit, right, again, is going to be the standard, and SI just means standard unit, is going to be meters. Now, when we want to calculate the distance, just think about it in terms of Google Maps. So when you enter an address and you want the directions, it's going to tell you to go 2 miles one way, 3 miles this way, 4 miles that way, 17 miles this way. But what they're doing is in the end, they're saying, okay, you have traveled this far. Okay. Because they're going to take every little step along the way. So distance matters how you get there. Okay. Now, on the other hand, displacement. So when an object moves, we say it has been displaced. Now, displacement is going to be the change in position of an object. Now, the SI unit, because it does answer that question of how far, is also going to be meters. If you look at the variables, they look very similar, right? X, delta X. But this delta is probably the most important way to distinguish them. Now, you ready for your first physics formula? Here it is. Very uneventful because there's nothing really complicated. So if I want to calculate the displacement of an object, I'm going to simply subtract the final position minus the initial position. Okay. So this delta, forgot the L, right, means change. And what does it mean by change? I go from final, I start at a position and I end at another position, right? So delta mathematically means final minus initial, regardless of what quantity is changing. So here is that first ever physics formula, right? Delta X, or displacement, is equal to final position minus initial position. Okay. And so just a little bit of recap again. Distance, so this would be a distance traveled, because it's going to say you're going to go this way, that way, this way, that way, and then add it up until you traveled this far, right? What else does that? Right? These nice fitness trackers, right? Here's my Garmin. If I go and check out and do some little things, I'm going to find something that looks very similar to this. And what that means is, based on how the movement of that watch has happened, it's gone 0.14 miles. Now, when we look at it here, okay, if I travel, if my motion is in the positive direction, which means I'm heading to the right of the origin, my displacement, my delta X, is going to be positive, right? Because how does it happen? Delta X equals 6 minus 2, right? 6 minus 2 is positive 4 meters. Now, interesting enough, the distance traveled is 4 meters. Okay. Now, if I go over to the other picture here, sorry, I know it got a little crazy there. Um, Note if I'm going towards the origin, right, or if I'm going away from the origin in the negative direction, my delta X will be negative. So if I look at the math of it, it'll be my final position, which ends up being 2 meters, minus my initial position, which is negative 4 meters. But again, here's the interesting thing about this. My distance traveled is 4 meters. So something that you don't see in distance, that you see in displacement, is the sign. Okay, displacement needs a sign or a direction, distance does not. Okay, so let's look at a quick example. All right. So the example here says you're walking to your friend's house, which is the origin, which is 2.1 kilometers away from your house, to pick up your friend to get something from the grocery store. That is 4.3 kilometers from your house. What is the distance you traveled, and what is your displacement? Okay. So here's our path, right? We're going to start at our house. We're going to go to our friend's house, which means we've walked 2.1 kilometers. Now we're going to go back towards our house because the grocery store is on the other side of our house, and we're going to go 2.1 kilometers to go back to our house, and then we're going to walk the final 4.3 kilometers to get to the grocery store. So the distance means I'm going to go 2.1 plus 2.1 plus 4.3, which tells me I've walked a distance of 8.5 kilometers. Okay. Now, one thing you need to know is that your distance and displacement may not always be the same. If it is a straight line from where you start to where you end, then yes, it will be they will be equal. But what happens here? Notice that we go towards our friend's house, but then we go back towards our house. But so basically, in terms of displacement, we've essentially canceled out that portion of the trip, because we go negative 2.1 kilometers and then we go positive 2.1 kilometers, which means my displacement is just simply from my house to the grocery store, which we don't have to do any fancy calculation because it's just given to us as 4.3 kilometers. Okay, so again, not a very eventful first video, but in the next video, we're going to look at speed versus